The Hubble Space Telescope has been in space for over 34 years, and in that time, its mission has far exceeded expectations. While it wasn't originally designed to observe objects within our solar system, Hubble has become an invaluable tool for unveiling the mysteries of our cosmic neighborhood. By capturing breathtaking images and gathering detailed data, Hubble has helped scientists explore a variety of celestial bodies, revealing hidden wonders that would have otherwise remained unnoticed. Most people associate space exploration with distant stars, galaxies, and nebulae, but our own solar system is filled with incredible phenomena waiting to be discovered. Some planets and moons have their own dedicated missions, but many remain largely unexplored, especially the small objects that orbit in the outer reaches of our solar system. In this video, we'll take a grand tour from our home planet, Earth, to the distant reaches of the solar system, exploring fascinating objects that you might have never even heard of, many of which were uncovered by Hubble's sharp gaze. We begin our cosmic journey close to home, with our nearest celestial neighbor, the Moon. While the Moon's large size in the sky makes it an obvious target for study, Hubble faces significant challenges when trying to capture the entire surface in one image. Due to the Moon's proximity, other missions, such as NASA's Lunar Reconnaissance Orbiter, are far better suited to provide detailed imagery. However, Hubble's time is often better used for other observations. Yet, in 2012, it captured a fascinating event that showcased its incredible capabilities. Venus passed directly in front of the Sun, and scientists used the Moon as a massive mirror to help study the planet's atmosphere. By observing subtle variations in sunlight as it scattered through Venus's atmosphere, Hubble was able to gather vital information about the chemical composition of Venus's air. Although we already know a lot about Venus, this method was used to test the accuracy of light scattering techniques, tools that Hubble frequently employs to study the atmospheres of distant exoplanets. Although Hubble faces challenges when observing the Moon, its observations of Mars are much more straightforward. Hubble often provides stunning views of Mars, revealing the entire surface of the red planet, something that orbiting spacecraft can't always do. These images are invaluable to scientists, offering insight into Martian dust storms, seasonal changes, and other atmospheric phenomena. One of the most remarkable observations Hubble has made was of a global dust storm that engulfed Mars, obscuring surface features for weeks. In a time-lapse sequence, Hubble captured the rapid motion of Mars's two small moons, Phobos and Deimos, as they orbited the planet. Phobos, the larger of the two, is especially interesting because it orbits Mars faster than the planet rotates, taking just 7.5 hours to complete one orbit. This makes Phobos the fastest orbiting moon in the entire solar system, and its quick movement is clearly visible in Hubble's time-lapse. As we move away from the inner planets and into the asteroid belt, we encounter a fascinating region filled with objects that reveal a chaotic yet beautiful part of our solar system. One of these objects, asteroid 6478G, is particularly intriguing. Although it might seem like a comet at first glance, thanks to its twin tails, this object is actually an asteroid. How can an asteroid have a tail? Scientists believe that a phenomenon called the Yarkovsky-O'Keefe-Radzievsky-Paddock effect is responsible. Solar radiation pushes on irregularly shaped objects, gradually speeding up their rotation. In the case of 6478G, its rapid spinning, one complete rotation every 2 hours, has caused loose material to be ejected, creating the asteroid's comet-like tails. Over time, this asteroid will likely disintegrate completely, much like many other fragile, rubble-pile asteroids in the belt. Though most asteroids in the belt follow relatively stable orbits, some venture too close to the massive gravitational pull of Jupiter, the solar system's true vacuum cleaner. Jupiter's immense gravity has shaped the fate of many objects in the asteroid belt. One dramatic example occurred in 1994 when comet Shoemaker-Levy 9 ventured too close to Jupiter. The planet's gravity captured the comet, tearing it apart and scattering its fragments across space. These fragments eventually collided with Jupiter's atmosphere, generating fireballs and impact scars the size of Earth itself. This event marked the first direct observation of an extraterrestrial collision, and underscored the role Jupiter plays in protecting the inner solar system from potential asteroid or comet impacts. But Jupiter isn't just a cosmic vacuum cleaner, it also boasts one of the most stunning displays of auroras in the entire solar system. While Earth experiences auroras thanks to the interaction of solar wind with our magnetic field, Jupiter's auroras are even more intense. In fact, they're hundreds of times brighter than Earth's and are constantly active, unlike Earth's auroras which occur sporadically during solar storms. Hubble's ability to observe ultraviolet light allowed scientists to study Jupiter's auroras in greater detail, revealing that they're not solely driven by solar wind. Instead, Jupiter's powerful magnetic field and radiation belts are thought to contribute a significant amount of charged particles, fueling these continuous auroras. This discovery has led scientists to reconsider how auroras are generated on other planets, challenging our previous understanding of these spectacular phenomena. Jupiter's moon Europa is another subject of great interest. Europa is one of the best candidates for finding extraterrestrial life within our solar system, not on its surface, but beneath it. Beneath Europa's icy crust, scientists believe there is a subsurface ocean of liquid water, kept warm by tidal forces generated by Jupiter's immense gravity. Hubble has been instrumental in observing this moon, detecting water vapor plumes erupting from Europa's surface. If these plumes are indeed composed of water from the subsurface ocean, it would support the hypothesis that Europa could harbor life in its depths. Hubble has also helped scientists study Europa's surface in visible light, detecting salts, likely from the ocean below, on the moon's surface. This exciting discovery adds weight to the idea that Europa's ocean could support hydrothermal activity, similar to the environments on Earth where life thrives near underwater volcanic vents. After leaving the gas giants, we head toward Saturn, the second largest planet in the solar system. Since the Cassini mission ended in 2017, Saturn has been without a dedicated spacecraft. However, Hubble continues to provide invaluable observations of this iconic planet, including monitoring seasonal changes and dramatic storms on Saturn's surface. Saturn's famous rings and atmospheric phenomena are captured in stunning detail, showing us just how dynamic this gas giant is. Next, we reach Uranus, one of the most unusual planets in the solar system. Uranus's extreme tilt, its rotational axis is tipped so far that it essentially rolls along its orbit, makes it stand out from the other planets. This peculiar tilt also means that solar eclipses on Uranus are incredibly rare. In 2006, Hubble captured an extraordinary event when the shadow of Uranus's moon, Ariel, passed across the planet's surface. Hubble's observations have also provided insight into seasonal changes in Uranus's atmosphere, which undergoes shifts in color as the planet moves through its 84-year orbit. Finally, we reach Neptune, the outermost of the ice giants. Neptune has long been a mystery since the Voyager 2 flyby in 1989, but Hubble has continued to provide important data. One of Hubble's most remarkable discoveries came in 2013 when it identified a new moon around Neptune, Hippocamp. This tiny moon may be a fragment of Neptune's much larger moon, Proteus, and its discovery was made possible by Hubble's ability to revisit archival data. This discovery adds another piece to the puzzle of our solar system's formation, highlighting the role of slow-moving collisions in the creation of moons. As we reflect on these discoveries, it's clear that Hubble has been instrumental in expanding our understanding of space and our solar system. Its ability to observe distant and nearby objects in unprecedented detail has helped scientists uncover countless mysteries, and its mission continues to push the boundaries of space exploration. With proper care, Hubble could continue operating until 2040, possibly outliving its successor, the James Webb Space Telescope, and continuing to inspire new generations of space enthusiasts and scientists alike. If you enjoyed this video, don't forget to give it a thumbs up, share it with your fellow space enthusiasts, and subscribe.